Hello students, myself Mr. Kiran Inswalkar, lecturer in Mechanical Engineering Department from Praveen Patil College of Diploma Engineering and Technology. We start the first chapter, Fundamentals of Machining and Machining Operation. We are studying in this part, this is the part number 2. Learning outcome. After watching this presentation, you will able to know introduction to lathe machine, second, how to classification of lathe machine, third, size and specification of lathe machine, and fourth, lathe accessories. Now we study in this chapter the most important machine, that is lathe machine. The main function of the lathe machine is to produce cylindrical job by turning. It is also capable of doing other operations as drilling, reaming, boring, taper turning, knurling and thread cutting, etc. The main basic parts of the lathe machines following are the important parts of the lathe machine. First part is a bed, second part is a headstock, third part is a tailstock, fourth is a carriage, fifth is a feed mechanism, and sixth is a screw cutting mechanism. This is a diagram of lathe machine. The main part of the lathe machine is a bed. Bed is situated at the bottom of the lathe machine. Okay, the bed is the main supporting structure of the machine. It gives support to headstock and tailstock at either end. On the top of bed, 4 accurately finished guideways are provided to slide tailstock and carriage. Bed is a cast with a cast iron, probably grey cast iron. Bed is made of cast iron. And on the left hand side and top of the bed there is a headstock. Headstock is permanently mounted on the left end of the bed. You see from the diagram headstock. Then function of the headstock. First function is to support the spindle. Second, to carry the driving mechanism forward. Third, to give the multiple speed to the spindle. Then the third part is tailstock. It is also known as a dead center. It is mounted on right hand side of the bed. Function of the tailstock to provide support to the end of the workpiece. Second function, to hold and feed cutting tools like drills, reamers, taps. Third function of the tailstock is to turn a taper on the job by tailstock set over the method. Then fourth part is a carriage. Carriage you can see on the diagram at the center of the machine there is a carriage. The lathe carriage supports and controls the movement of the cutting tool. It consists of following parts: saddle, second cross slide, third compound slide and or compound race, fourth is a tool post, and fifth is a apron. From this diagram we see that various parts of the lathe machines. In previous slide we see the 2D diagram of the lathe machine, but in this slide we see the actual 3D diagram of the lathe machine. We can see from the left hand side. On left hand side you see that there is a headstock, and if you move from left to right, then there is a spindle and chuck. Spindle and chucks is mounted and carries in the headstock. Then middle portion is a tool post. Tool post, compound race, cross slide, saddle. On right hand side of the lathe machine there is a tailstock. There is a hand wheel, guide wheel, bed, feed rod. There is a apron, carriage and lathe. You can see the various parts of the lathe machine. We see the various parts of the lathe machine. Now in this slide we studied classification of lathe machine. Lathes are manufactured in a variety of types and sizes, from very small bench lathe for precision work to large one for turning the steel shaft. Classification of lathes according to their design. First is a speed lathe. Second is an engine lathe or center lathe. Third is a bench lathe. Fourth is a tool room lathe. Fifth is a capstan and turret lathe. Sixth is a special purpose lathe. And seven is a automatic lathe. Then we study this all lathe in a details. First is a speed lathe. We can see the diagram of the speed lathe. It is so named because its spindle rotates at very high speed, about 400 rpm. Second point, speed lathe is the simplest form of all types of lathe. It consists of a bed, headstock, tailstock and two rests. Third point, it has a cone pulley which provides speed variation to the spindle. The fourth point, the tool used are operated purely by hand control. Second lathe is engine lathe or center lathe. Engine lathe or center lathe is actually we are uses in our workshop. Then we have studied the engine or center lathe. First point, an engine lathe is most important member of the lathe family and widely used in a machine shop. Second point, it is driven by separate electric motor or number of lathe is driven by overhead shaft with help of belts. Third point, the main parts of the engine lathe are bed, headstock, tailstock and carriage. Fourth point, headstock of the engine lathe contain additional driving mechanism which gives multiple speed to the lathe spindle. This engine lathe we are actually uses in our workshop. Next lathe machine is a bench lathe. A bench lathe is a small engine lathe which can be mounted on bench. Second point, this type of lathe is used for small and precision work. Third point, in construction, it is very similar to the lathe or speed lathe and it can perform all the operation as that of engine lathe, but only difference is in its size. Next machine, tool room lathe. First point, tool room lathe is an engine lathe equipped with an extra attachment for more accurate and precision work carried out in a tool room. Second point, a tool room lathe equipped with a steady race, quick change gears, lead screw, dial gauge, feed rod, taper turning attachment, collects and chuck, etc. Third point, a tool room lathe is carefully tested for its accuracy and having considerable range of speed from very low to as high as 2500 rpm. This type of lathe is more expensive than engine lathe. Next machine is a Capstan and turret lathe. First point, the construction of this type of lathe is similar to the engine lathe, but only difference is that tailstock of engine lathe is replaced by hexagonal turret. Second point, on the face of hexagonal turret, multiple tools may be fitted and feed into the work in a proper sequence. The advantage of hexagonal turret is that the number of different types of operation can be done on workpiece without resetting workpiece or tool. The main advantage of Capstan and turret lathe is that in engine lathe, speed lathe or other lathe, there is a changing of tool when different operations are performed. For different operation, different tool is required. So in normal lathe machines, there is a different tools are setting as the operation changes. But in capstan and turret lathe, you can see that on right hand side, then on the tailstock there is a turret or there is a attachment of the various tools. The main advantages is that we can turn various operations without resetting workpiece or tool. Next machine is special purpose lathe. First point, special purpose lathe is modification of engine lathe to perform special operation. Second point, it is designed to perform specific operation only. Third point, special purpose lathe are used to manufacture the job which cannot be convenience produced on a standard lathe. Seventh machine is automatic lathe. First point, these types of lathe are used in a mass production. Second point, these lathe increase the quality and quantity of the production. Third point, they are so designed that all the operation of manufacturing processes are carried out automatically. Fourth point, participation of the operator is completely eliminated except the inspection. In automatic lathe, all operations perform automatically. There is no need of any operator for the operate the machine. Only inspection purpose operator is needed. In this slide, we study size and specification of the lathe. When any person, when going for purchasing any lathe machine, following specification is to be considered. First specification is length of bed. This is denoted by capital letter A. Length of bed is the distance between headstock and tailstock. Then second point B, distance between center. It is denoted by B. Distance between center is the maximum length of the job can be accumulated in the two center. Point C, diameter of the work that can be done over the ways. C is the maximum diameter of the workpiece that can be revolved. And then D, diameter of the work that can be done over the cross line. These are specification of the lathe machine. Then we are studying lathe accessories. Lathe accessory is not a part of the lathe machine. These are extra attachments which are provided on the lathe machine. The lathe machine are provided with different accessories. Lathe accessories are used for first is for holding and supporting the work. Second, holding the tool. Mainly lathe accessories are used for holding or supporting the work and for holding the tool. The following accessories are employed on lathe. First is center, second is chucks, third is a face plate, fourth is a driving plate, fifth is a angle plate, sixth is a mandrel, seven is a rest, and eight is a lathe dog or carrier. These are some accessories which are used in a lathe machines. In this slide, we study in details the various lathe accessories. The first accessory is a center. The lathe centers are used for supporting the work during turning operations. The work is held between live center and dead center. In this diagram, we see that there is a ordinary center, then second is the insert type center, third is a pipe center, sixth is a curve or reverse center, fifth is a half center, sixth is a U of half center, and seven is a odd center. Now we study what is meaning of live center and dead center. First we study the live center. The first point is the center which is fitted in the headstock spindle is called as a live center. The second point is support and at the same time revolves with the work. It is called as a live center because of its revolve with the work. Second center is a dead center. The first point, the center which is fitted in the tailstock is known as a dead center. Second point, it supports the other end of the work but does not revolve with it. Third point, these centers are made of hard steel. Fourth point, they have taper shanks of 0 to 6 more standard taper. Fifth point, they are included the angle of core 60 degree for general purpose and 75 degree for heavy work. Now we study the next accessory is a chucks. Chuck is the one of the most important devices for holding and rotating the piece of the work on the lathe. A chuck is attached to the headstock spindle by the means of bolt with back plate and set screw on the spindle nose. Then there are various types of chucks. First is a 3-jaw chuck, second is a 4-jaw chuck or independent chuck, third is a magnetic chuck, fourth is a combination of chuck, fifth is a collect chuck, sixth is a spindle chuck, and seven is a air operated chuck. Now we study 3-jaw chuck. In diagram we can see the 3-jaw chuck. 3-jaw chuck, there is a various part. On left hand side there is a 3D diagram. We can see the various part, that is key socket, scroll, back plate, external jaw, chuck key, body, internal jaw. On right hand side you can see the jaw and work. The 3-jaw chuck, the first point, is also called as a universal or self-centering chuck. The 3-jaw move simultaneously in or out by an equal amount when the scroll wheel is made to rotate by rotating any one pinion with the help of a chuck key. The 3-jaw chuck is called universal or self-centering chuck because if you move the one jaw with help of key, the other two jaw move in an equal amount. Now, now we see the advantages of 3-jaw chuck. First advantages is that the job can be held easily. The job is centered automatically and quickly. Second advantage, a wide range of round, hexagonal or regular shape workpiece can be held in the chuck. Third point, internal and external jaws are available. Fourth point, the workpiece can be bowed also. Then there are some disadvantages of three-jaw chuck. First, only regular components can be held, that is, example for round, hexagonal, etc. Second point, accuracy decreases as chuck become worn. Third point, runout cannot be corrected. Fourth point, accuracy of concentricity is limited when work is reversal in the chuck. Fifth point, gripping efficiency is low. Next, next type of chuck is four-jaw chuck. In the diagram, we can see that in four-jaw chuck there are four jaws. The four-jaw chuck is also called as independent chuck. It consists of four jaws. Third point, each jaw can be adjusted independently by rotating the screw, which is meshes with the teeth cut on the underside of the jaw. Fourth point, this types of chuck is particularly used in a setting of heavy and irregular shape of work. In case of three jaw, there is a cylindrical jaw or hold and we are doing operation. But in case of four jaw, we can hold a irregular shape of work. Now we study the advantages of four-jaw chuck. First point, jaws can be reversed for holding externally or internally on the workpiece. Second point, a wide range of regular and irregular shaped job can be held in the chuck. Third point, chuck possesses high gripping power, therefore heavy cuts can be taken. Then now we are studying limitation of four-jaw chuck. First point is consume more time for setting up a job in a chuck as compared to the three-jaw chuck. Second, because of high gripping power of chuck, fine work can be easily damaged during setting. Third point, chucks is heavy to handle on the lathe. These are some limitations of four-jaw chuck. Now we study next chuck, that is magnetic chuck. First point, magnetic chuck consists of powerful magnet inside housing body. Second point, the holding power of the chuck is obtained by a magnetic flux radiating from the magnets. Third point, in the on position, flux passes through the workpiece and grab it. Fourth point, this chuck can be used to hold the material having magnetic property. Fifth, complicated jobs which are difficult to holding other chuck can be held on it without elaborated use of clamping. Sixth, it saves lot of time required for clamping in other chucks. Next accessory is a faceplate. First point, it is a cast iron circular disc having a threaded hole at its center so that it can be screwed on the threaded nose of the spindle. Second point, there are a number of holes and slots provided on this plate. Third point, it is used for holding the work which cannot be held between center or on the chuck. Fourth point, the work is held with the help of clamping plate and bolt. Next accessory is the angle plate. First point, angle plate is a L-shaped cast iron plate. Second point, two faces of the plates are at right angle and having slot for clamping the face plate on its surface. Third point, it is used for holding the work which is not possible to mount directly on the face plate. Next accessory is a mandrel. First point, mandrel is the device used for holding and rotating a hollow workpiece that has been previously drilled or bored. Second point, it is a solid shaft made of high carbon steel. Third point, it is mounted between the centers and work revolves with it. Fourth point, it is driven by driving plates and carrier. Different types of mandrels are plain mandrel, collar mandrel, cone mandrel, expansion mandrel, and step mandrel. Actually, in case of lathe machine, the workpiece is held between the two center. But if the workpiece is hollow, like a take example of pipe. Pipe is a hollow. So these hollow pipes we cannot held between the two center. So that mandrel is a solid shaft. On the solid shaft enter inside the pipe, and this mandrel is supported between two center, and we can easily work on the pipe. Now we see the different types of mandrel. First is a plain mandrel. First point, the body of the plain mandrel is slightly tapered. Second point, this taper is provided for proper gripping of the workpiece. Third point, it is mostly used for standard size work and repetition jobs. Fourth point, every workpiece of different internal diameter requires separate mandrel. Next mandrel is a collar mandrel. A collar mandrel is used for holding larger diameter workpiece. Second, a diameter of about 100 mm and above is held by the collar provided on the mandrel. Third point, collar type construction reduce the weight as compared with the plain mandrel for the same size workpiece. Fourth point, for different size workpiece, different mandrels are required. Next mandrel is cone mandrel. First point, a cone mandrel consists of fixed type cone and sliding cone which can be adjusted by means of nut provided on the threaded end. It is used for holding higher diameter holes of various dimensions. Next mandrel is an expansion mandrel. First point, expansion mandrel is used to reduce the number of mandrels required for holding different diameter of work. Second point, common type of expansion mandrel consists of a split sleeve which is mounted on an inner mandrel. Third point, this sleeve is tapered and parallel outside. Fourth point, the work is mounted on the sleeve which expand within the certain limit when the inner mandrel is pushed through it. Fifth point, this type of mandrel is used for holes of all sizes. Next mandrel is a step mandrel. A step mandrel has steps of different diameters. Step mandrels can hold the work of different sizes which save the time required for replacement of mandrel for different sizes. Now study the rest. First point, a rest is a device which is used to support long slender jaw at an intermediate point to prevent from bending due to its own weight and vibration caused by cutting forces acting on it. Second point, rest will be used when the length of workpiece is more than the 12 times of its diameter. Common types of rests are steady rest and follower rest. Actually, this rest is a lathe accessory which are used for the support the long slender job. Now we study the steady rest. In the diagram, on left hand side there is a 2D diagram. On left hand side, in the steady rest, at the center there is a circle which are hatching, and there is a 3 jaws, and at the hinge this steady rest is mounted on the bed. On the right hand side we see the 3D of the steady rest. This is a steady rest which support the workpiece. Steady rest is also called as a center rest. This rest, this rest remains stationary at one position with respect to tool. It consists of cast iron frame and 3 adjustable jaws. The frame is made of 2 parts which are hinged at one end to give facility to easy setting and removing of workpiece. The bottom portion of the rest has grooves corresponding to the lathe bed wedge and can slide on it. Rest can be clamped at any desired position where support is required. Next rest is a follower rest. On left hand side we can see there is a tool work. In follower rest there is no 3 adjustable jaws as like in a steady rest. In follower rest there are 2 adjustable jaws and third side is supported by the tool. On right side we can see the follower rest. The follower rest also known as a traveling rest. This rest move along with the tool during turning operation. It consists of a frame with 2 adjustable jaws. The jaw can be adjusted to support the work between them and turning tool. The frame is attached to the saddle of the carriage and travels longitudinally along with the tool to give continuous support to workpiece. The follower rest is used to support the flexible jaw to prevent them from springing away during the turning operation. I hope you understand this presentation. Thank you.